Good morning, good afternoon, and good evening, everybody, depending on where you have joined from. My name is Aditi Ergal, and I'm your host today. I work as an associate manager marketing at ImageVision.ai, and I will be hosting this session today. First of all, I'd like to thank all of you for registering and taking the time to join us today for this webinar on 360-degree bottle surface defect detection using computer vision. Before I start discussing about our company, I would like to introduce some webinar rules. Firstly, there will be interactive polls which will be coming along throughout the session of the webinar at an interval of 5 minutes each. And as far as the Q&A is concerned, you guys can keep sending us your question and answers during the session as and when you feel like, and we will take them at the end of the session. For any queries or any doubts and any other business requirements, you can reach us at info@imagevision.ai, or simultaneously you can reach us at hello@imagevision.ai as well. Now I would like to talk about our company in brief. At ImageVision.ai, we empower businesses with computer vision for smarter decision making. We leverage computer vision to empower industries by achieving unprecedented automation, accuracy, and productivity levels, transforming how businesses operate and thrive in the digital age. With a customer-centric approach, we are committed to delivering pioneering, reliable, and scalable computer vision solutions that address practical challenges and drive tangible results. Our solutions improve business processes, product quality, customer experiences, and drive innovation for sustainable growth. We are led by a team that has industry expertise and visionary insight that shapes the strategic direction of our organization. Now, let me discuss in brief about the ImageVision.ai landscape. As you can see, we cater to the various industries such as packaging, security surveillance, bottling, transportation, healthcare, pharmaceutical, and FMCG. Some of our key features or capabilities include package counting, label inspection, drone monitoring, foreign particle detection, and surgical instrument tracking. Now, let me discuss in brief about the webinar topic and our agenda for the day. The bottling industry holds a substantial economic significance due to its considerable contribution to the global market. According to estimates from 2022, its value was estimated to be USD 303 billion, and projections indicate a compound annual growth rate of approximately 6% from 2023 to 2030. The escalating concerns surrounding the consumption of contaminated water, which have been linked to gastrointestinal diseases, have resulted in an increased demand for cleanly packaged and hygienic alternatives. This webinar provides insights on bottling industry and how, with the help of 360-degree surface defect detection, we can help provide high-quality bottling products to the customers. We will walk you through the potential pitfalls and best practices which you need to adopt, as our experts have implemented multiple projects in this domain. We will also talk about our client experiences and emerging trends in the bottling industry. In this webinar, as you can see, we will address the following agendas. Firstly, the importance of an accurate and high-performing quality inspection process in the bottling industry. Secondly, challenges with manual inspections and their impact on business productivity and scalability. Thirdly, how AI can assist with quality inspection and its differences from primitive image inspections. Fourthly, creating a robust and explainable model for bottle inspection. And lastly, adapting the model to varying characteristics and challenges from the production line. Now, we have come to this part of the webinar where I'll be introducing our speakers for the day to all of you. So we have our first speaker, Renu Sharma, who spearheads product innovation as Vice President for ImageVision.ai. With over 20 plus years of experience in developing tailored industry-leading artificial intelligence and machine learning solutions in computer vision and analytics domain, during this period, he has been closely working with customers and organizations, helping them with their digital transformation journey. Next up, We have Bhavika Patel, who works as a lead data science engineer at ImageVision.ai. She's a statistics graduate with over 10 plus years of work experience and has hands on experience in statistical data analysis, statistical modeling, machine learning, deep learning, and computer vision. I will now hand over the stage to Greenu. Greenu, please take it ahead from here.
Okay, thank you, Aditi, for the introduction and for setting up the expectation for the session. I once again welcome all our audience to this session, and upfront thanks for taking out your time and showing interest with this webinar. Okay, let's to begin with, I'll start with a quick overview about the bottling industry before we do a deep dive discussion on each of the specific formats. If you see the bottling industry over the years, there has been a substantial growth, as Aditi was briefing it, and the market value growth is really significant. And this industry is suspected to be growing much higher with more and more customer demand for the bottling part. There are many reasons for this, and few being the increasing health consciousness among the consumers and the demand for the potable drinking water, and the rise in the middle class has contributed to this growth. When there is a demand and then you see the market opportunities are there, it varies with the region. If you see the developed market, the industry focus on premium and functional waters are high. For the developing market, the opportunities are for basic and premier offerings. The bottling industry is highly competitive with multi-level players in the market. And sustaining in this industry becomes a major challenge with the competition, and companies adopt various innovative approaches to differentiate their product from the competition and make a mark. That could be many ways. It could be maybe for focusing on their packaging, coming up with innovative ideas for that, how the content is packed, how the content is inspected, bringing in different flavors, minerals, etc. Down the line, earning a consumer trust and preference is the key, and that could be only happening by increasing the quality of the product. Recent industry study reveals that most of the inspection visual systems which are established in the industry are based on the legacy systems. And there is a growing concern on the quality of products reaching the consumers. This really impacts the industry with escalating consumer complaints, increased product recalls, hurting consumer and bringing huge economic loss and brand degradations. ImageVision have been serving the bottling industry since many years, engaged with automating the manual inspection process at various stages of production. We have been working not only with water bottling plants, but also with other beverage and packaging industry. The challenge of automation varies with the industry, and we provide custom solution based on specific industry needs. Today in this session, we pick up water bottling industry as a case study, and we'll cover major challenges in this industry, inspection solutions, what we see, and some key insights that is helping this industry in providing quality product to the consumers. Moving forward. So anywhere during the session, actually, if any of the attendees have questions, please feel free to note it down. Towards end, you will have a question and answer session so that we can refer back to those and answer those things. Back to the topic. So I want to just also talk about the technology landscape where it helps with the bottling industry. Before we get into the specifics of bottling industry, we would like to quickly touch upon the opportunities of improvement with respect to applying technology at various stages of the production line. Inspection is what we primarily focus on, where we could bring in much quality improvement and cost savings. Now, when you talk about inspection, the first one comes into mind will be the bottle inspection stations. The objective will be to ensure that the integrity and quality of bottles are ensured before they are filled. This is applicable for the empty bottles. And what are the defects you see for here? It will be cracks, chips, or any physical defects which can get into the bottle. So applying computer vision with different sensors can enhance the quality of inspection in bottle inspection stations. This is one of the things which we can think about when we talk about bottling industry. The next one which comes to mind will be the fill level inspection. So the objective for this particular inspection technology will be to ensure that the right amount of liquid is filled in each of those bottles. This has become a major concern where when there are leaks or malfunctioning in the filling system, the bottle doesn't get filled, and then that become a big issue with the quality. So we have visual as well as other sensor systems which can be used to check the fill level and alert and reject the bottles at the production line. Next one be the label inspection. So this is again as part of the bottling industry. Once the bottles are filled, the system, the label printing system will be printing the labels onto the bottle and sealing the caps. So there are many defects which can come, which will have we not noticed or corrected well, have high impact with respect to delivering to the consumers. So we use various modeling techniques as well as OCR and other reading tools to make sure that the label is printed fine, the labels are printed right with alignment and visible to the consumers. In that way, we are making sure that the integrity of the bottle which is packed is correct before it leaves the production line. Packaging and carton inspection is another area where we'll employ this computer vision and AI inspection techniques, where when the bottles are packed in cartons, the counts are checked, verified. The seals, where the package is actually correctly sealed or not, is verified. The packages are even classified according to the size and shape so that it can be diverted to the right conveyor production lines. Here we use weight sensors, barcode readers, thermal sensors to see whether if the packaging is done through thermal imaging. Cameras are used for doing that, and the vision system for classifying and counting the bottles. Moving on. Leak detection system is at another area where we can apply vision techniques based on the place at which we are performing the detection. So when you talk about leak detection, it can be applied for empty bottle as well as for filled bottles. So technology what we use for detecting leak in empty bottle will be different from the technology what we use for detecting the leak in the filled bottles. So normal cases, it cannot be done only with vision, because when vision is used, cracks can be deceiving sometimes. Whenever there are cracks, which are lines cracks or scratches, the vision system can get fooled. So false predictions can happen. So we combine vision system along with other leak detection techniques like pressure sensors, and then water sensors to make sure that the leak is detected before the bottle leaves the production line. Next prominent one which we see and deploy in this bottling industry using modeling is the cap inspection system. Again, before the filled bottle leaves the production line, we need to ensure that the caps are fitted in tight without any chance for what the content getting leaked. The labels are being printed and the alignments are straight so that it is intact to the production line. So here also we use computer vision and different sensors to ensure that the defects are detected upfront and that doesn't reach the consumers. Next, there are many inspection systems as we discuss here, and then we also consolidate all these models which we have described in the previous session, and have a final inspection system where the integrity of the filled bottle is being checked. It could check the bottle type, the size of the bottle, the alignment of the bottle, the cap alignment, the labels are printed, the barcodes are printed, the expiry date is right or not. So all things can be single integrated in one model and delivered to the customer. So I just quickly went through some of the technology advantages and some of the use cases which are applicable in the in this particular bottling industry. There may be many like this, which can be used and then which can be implemented as part of the inspection. Now coming to the current slide, introduction to the visual AI inspection. If you look back, visual inspection is not something new which we are introducing. Many industries have adopted visual inspection long back using image analytics techniques, where a comparison, image reference comparison is used for detecting any type of anomalies. The improvement what we introduce here is the AI part. And the difference of both approaches we'll be detailing in discussion in the upcoming slides. Introducing AI on a high level help us in dealing with the dynamicity of defects, which is very common with this industry. Because we cannot predict what's the defects you may encounter in a bottle which is coming into the filling system. Now, when you see implementing a visual AI inspection as part of bottling industry, what is the key voice of the customer which comes out from the industry? Each customer will have a unique challenge and requirement while trying to automate their manual inspection process. A detailed system study should be performed first. The fraud plan has to be analyzed to understand the right fitness of the visual inspection solution. Now, designing an adaptable hardware system that could integrate easily with the existing production line with minimum footprint is one of our key constraints. Now, all the customers, what is the need is that the new system what we want to integrate should not have any impact on the current production throughput. It should either meet or exceed the current limits. It should never decrease the production throughput of the existing system. And designing the system, deciding the components, we should consider the environmental factors that include temperature, humidity, dust, water, light, whatever it is, because this is an industrial environment, right? They should not impact the hardware and the software, and it is reliability in the performance. Another insight what we have to see while designing this system, which we have taken care, is the regulatory standards which are applicable to the regions where we are planning to install. And one of the key things which we hear from our customer when we are talking about installing this system is easy installation. What is your lead time? Because they don't want a shutdown the production line, because this is most of the bottling plant, they run 24/7. They don't want more lead time where the production has to be down. And another thing is the repair and maintenance process and minimum footprint. Few things which come as key CTQs from the customers. Again, when it comes to the bottling plant, when you design a system, we always look at how much adaptable and reusable the system should be so that it will support different bottle profiles, because mostly 5-gallon bottles which comes from the customer, each brand will have different flavors of it. So when they really approach us for a solution, they also mention that the bottle profile should be supported. And then in future also, if there are some sort of small variation coming in, the machine should bring in some sort of tolerance so that there is no huge changes which is needed for them to support the new profiles. And sometimes what we face challenges in this particular industry with AI inspection is blind spots due to the peculiar design of the bottle which comes in. So basically, when we plan for introducing vision AI inspection, we don't see any off-the-shelf product which you can go and directly buy and install. You need to customize it. In summary, you need to ensure that you visit the customer and then see the infrastructure requirements there and plan your image acquisition and the processing system which suits the customer so that a quality product can be delivered to them. With that, I will move forward and request Bhavika to take it over and talk about the few of the challenges and some of the internal details of how this bottling inspection system works with AI. Over to you, Bhavika.
Thank you, Grinu, for the elaborate introduction of our AI vision inspection system. Coming back to the challenges in the bottling industry, as just introduced that the inspection in the bottling industry can be done at different stages in the production line. When it comes to the bottle inspection system, there are 4 major stages usually we come across. Pre-wash station, after washing of the bottle, refilling the bottle, and post-filling the station. The most crucial stage out of all is inspecting at a station before filling the bottles. The main problem which we come across in this pre-filling process is finding the foreign particles inside the bottles, like tiny bits of glass, plastic, or even bugs or rodents. As these contaminants not only pose a severe threat to consumer health, but also can cause damage to the bottling machines. Many in this industry currently rely on manual inspection, which is time consuming and labor intensive process. Moreover, when it comes to identifying defects which are smaller and transparent in nature, especially in the transparent bottles, then there is a chance of missing them and passing the defect bottle for filling. In response to these challenges, we, ImageVision.ai, introduced a cutting-edge smart automation solution that can seamlessly integrate with the existing system by occupying minimal space and ensure the reliability of the system. Our proposed end-to-end 360-degree automated system leverage latest deep learning detection algorithm to enhance the accuracy of identifying various sizes and the natures of defects, along with the rejection of system which can reject the defect bottles from the production line easily. So complete end-to-end automated solution. Going forward, why AI deep learning algorithm? Earlier in this vision industry, as Genu said, most of the companies or the defect identification relied on straightforward approach. That is an image comparison approach. Basically, in this approach, they will have few images trained as accepted images and a certain variation is trained as defect. Internally, they use pixel comparison algorithm, which means it calculates the difference between 2 images, that is from the reference image to the captured real image. If there is a significant difference in the area of pixel values, then that has been trained for, then the algorithm calls it as a defect image. These basic algorithms face challenges, particularly in dealing with the fluctuations in lighting, often results in false positives, which means a good bottle will be classified as a defect bottle in the real-time production due to the variations in this image pixel values. Additionally, they also lack the capacity to grasp the contextual meaning of the detected differences. For example, if you can see that the left corner is a reference image for defect data, which is drained on both the models. The second column there are few defect images with variations. As I mentioned, the defect position is not matching to the reference image position, and a change in the brightness or contrast values of an image when there is an introduce of a new defect, which may have similar features. For such kind of cases, this traditional image comparison model doesn't recognize it as a defect, as it does not have that similarity with the trained image. On the other hand, impressively, pattern detection neural network algorithm goes beyond the pixel level analysis. They understand the contextual significance of defects, that's few features such as shapes, edges, colors, providing more insightful and accurate evaluation. Not only defect detection, these networks excel in a broad spectrum of analysis tasks, including pattern recognition, defect identification. So not only the AI intelligence we have incorporated, the other benefits in our AI inspection system, understanding the key CTQs from the customer. Here are our other key features, which is collectively positioned in our AI vision inspection system as an asset for quality assurance and production optimization. Starting with the capability of capturing images from 360 degree, reduces the likelihood of oversight and improves the overall efficiency of defect detection. In this, we can cover all the blind spots of the bottle and each and every corner of the product. Second, use of AI network, as I mentioned in earlier slide. This network enhances the precision and ensuring an accurate identification of even the smallest defects. With that strategy, our system can attain high precision value in defect detection, accompanied by minimal false rejections rate. Our system can enhance the production throughput as AI process data faster than human. So we can match the production throughput of current system and exceed than that. It has a capability of 24/7 inspection and can efficiently adapt to various production volumes, avoiding the bottlenecks. Be tailored to various bottle profiles. It is flexible and compatible with different product specifications. It can identify bottle brands as well. The built-in feature of defect tracing with image evidence allows for quick identification and resolution of production issues. This can also provide access to available data insights or analytics through comprehensive management reports. One of the most remarkable advantage lies is the continuous learning neural network architecture, which is enabled in the system, which can continuously improve and adapt over time for dynamic environments. All these features are being integrated in a single compact design. Now that we have covered the key features, let's delve into the underlying system components. Our system consists of 6 major components, which can be easily plugged and integrated with the existing system. First and foremost is image acquisition system. If you can see in the figure, you can see 4 stations. The second and the third station talks about image acquisition system. The name itself says that acquiring the images. With the help of cameras, proper lens, illuminations, and the sensors, we can gather high quality visual representation of the product. The images are only the source of information for analysis. Here, we carefully choose the right camera based on the product features and the distance between the product. Second is a vision software, which is nothing but the core image processing software, and the algorithm to detect the defects will be deployed here. So all the visual data which we gather in these stations will be processed for defect identification. Basically, this component drives the entire decision-making process to accept the bottle for filling station or to reject it, saying that it has some defect in it. Next is the system log, which serves as a documentation and memory system where we'll keep all the record of events, errors, information. That history will aid us in troubleshooting and quality control. The bottle ejection system, the station 4, which acts as a system hand. Once our vision software says that the coming bottle has some defect, then the system, this component will carefully remove that defect bottle from the production line. The motion control system, the entire coordination or the movement of the bottle from station 1 till the station 4 will be controlled by this system, this component. Last but not least, the AI ML model component, which represents our learning component of the system. By using the deep learning algorithm, we teach the different patterns which comes in the defects and try to continuously improve its ability to detect that defects in a real-time production line and reduce the false rejection over time. So let's see what is required to train an algorithm. Slide talks about the process of training an accurate AI model and securely deploying it in a production line. So usually when we train an AI model, the first and the foremost is the data collection step. When we try to collect the data, we try to collect the diverse data through the cameras, which will be a foundation for our AI model. To enhance the quality of the data collected for effective model training, we apply few pre-processing steps such as normalization, resizing, noise detection, enhancing its brightness or clarity of the image. Next step, once we enhance the data, we try to extract its learning features. When we say its learning features, means how the defect is, its edges, its colors, its shapes, its textures. So few of these features will be fed to our deep learning architecture to build a prediction model to understand the contextual of that defect. Trained model is ready. We test on an unseen data, which comes from the real time. And then this model gives us a prediction report. Using metrics such as precision, recall, we draw models' prediction results, which means we'll get to know that what is our efficiency of the model in the practical application. If metrics indicate a room for improvement, or if there is any change in the environment, the model undergoes retraining. This ensures the adaptability and continual enhancement based on the new data. Next slide. Moving on. System can detect various contaminants and anomalies that may affect product quality. Here are few defects that usually we find in a water bottle. such as foreign bodies like paper, pipe, insect, discoloration such as paint, oily substance, sediments, and dents. If you can see, some of these contaminants share a visual similarity with the water droplets, foam on the outer surface of the bottle, posing a challenge for inspection method. As initially we said, if we would have been using an image comparison model, then this would have definitely given us a challenge. But our AI inspection system possesses the unique ability to precisely classify and differentiate these kind of accepting criteria as water droplets or foams from the foreign bodies by utilizing sophisticated algorithms. Moving on. Here is one of the way where we can capture top to base of the bottle, covering all the blind spots of the bottle, ensuring no defects are left behind. You can say that why do we need multiple cameras? See, it all depends on the size of the product. If it can take the example here as shown, the 5-gallon water bottle, it is huge in the product size. With 1 or 2 camera, you can't capture all the 360-degree because of the foreign particles. As I mentioned earlier, we can find in the water bottles, such as paper, can be stick on any side of the bottle. It's not necessary that we can see from the top or the bottom. There is no such visibility. So using multiple cameras, we can ensure that we cover all the 360-degree, ensuring that we don't miss any of the spot for defect identification. Not only that, camera position, we also take few important while designing the system. First, rightly I said the camera position, but not only the camera position, we also consider the camera sensor selection. And the second point, if we are handling component, if a bottle handling component is required for some alignment, we do select a soft robotics or gentle gripping mechanism to handle the product without causing damage. In the design, we also consider the proper airflow in the system so that our cameras doesn't get heat up and result in no inspection or a shutdown. We do implement vibration and impact analysis technique to assess the structural integrity of the bottle without causing harm. This can be particularly useful in the industry where delicate components are involved, such as glass bottles or so. Design customized and adjustable fixtures or holders that secure the product in place during inspection without causing stress or damage. This can accommodate to various product shapes and size as well. Proper calibration to ensure that the system operates within specified tolerances. Before going to full-scale implementation, we do conduct an extensive testing on sample products to validate the non-destructive nature of the inspection system, as well as the defect identification by our AI model. This help us in identifying and addressing any potential issues. So here are a few points which we consider to build a reliable system and also maintain a less footprint to fit into existing system. I will hand it over to Greenu to provide some key statistics and insights on this product with real-time production data. Over to you, Greenu.
Okay, thank you, Bhavika. I think that was really interesting. And then I just before moving on to the insight session, I also want to just touch upon one of the challenges what we have faced during designing a system like this. Primarily, when we talk about AI models, the quality of the inspection really depends on the quality of your image, primarily on the image acquisition system, right? So Bhavika was touching upon the cameras, placements, and then considerations with respect to the environmental factors and all, right? So illumination is also something which we really need to be watchful based on the customer infrastructure. So proper lighting, you have to really do a proper lighting system check so that the images are captured by the camera, designated camera, in the right way. So when you have a quality image being captured, the quality of your inspection will be at its best. So we have in our 360-degree inspection system, we have adopted various type of techniques, illumination techniques like dark lighting, bright lighting, dome lighting, and backlighting. So which help us to avoid noises coming into the images, and also the shadows which falls across or reflection which gets into the system. These are all major things which actually uh, really impacts the quality of the inspection system. Yeah, so I just want to just make sure that that also had been discussed. Many challenges, interesting things were there, but in the interest of time, we are just moving forward with the next slide. Yeah, so the key takeaways. So this is something which I just want to mention. Primarily, the advantage just to enhance or to bring the notice of the participants to say that okay, fine. Finally, what is the key takeaway when what we get with respect to installing the system? First and the foremost, getting rid of the manual inspection system. Okay, so you know that when you're introducing automation, it helps the client to address the misses which can be caused due to human error. The human error can be due to fatigue, inattention, inconsistency in decision making, but the reason I mean sometimes the understanding of a defect varies from person to person. So whenever the shift changes, um, the standard also changes. So a defect for a person maybe not a defect for a second person who comes as a supervisor in the next shift. Those things we are seeing those type of things happening in the production line, and then the speed at which the inspections are made. Again, did the speed plays a major role in the inspection whenever there are scalability is required with respect to production throughput. The manual inspection becomes a bottleneck. When you want to increase the speed of the line, they may have to either two options. One is to include more resources, inspection stations, and then have more capable people who can actually run at higher run rate to detect the bottles. And with manual inspection, there are no actually accountability with respect to the number of defects, the type of defects, and insights, because we are not recording anywhere. Even if they record it, it's all manual entries, which are again prone to human errors. So many types of issues are getting resolved by introducing automation in the industry. Now, what automation brings in is scalability, high speed, standard, consistent detections, and then at a reduced cost. In addition to that, you have the data which is getting logged, which will be available for later analysis and insights. That is the first thing which I want to say as a key takeaway. Then we'll talk about the defects per hour. Definitely, there is no limit for a automation system how many defects you could be catching per hour, because these are all a continuously running system at a high speed. If you have people sitting over there, what we have seen is the defects per hour rate is again dependent on the efficiency of the person who is sitting there and the type of bottles which are coming in. So with inspection automation, which has significantly improved the defect rate per hour and thereby reducing the miss rate. Any defects missed, you know that it causes rework and greater chance for consumer disappointment. So that is another key takeaway which we could actually flag as part of the automation. Now, false detection is something which we have seen as a challenge primarily with automation. What we could actually see is initially with manual detection, the false rejection rates are lower because there are the chances of a human supervisor rejecting a good bottle is very rare unless otherwise there is some problem with the inspector. But when you install a automation system, the initial piloting stage, you see a slight increment in the false rejection rate because of more and more training need requirement. But we have seen that down the line with proper training and optimization, those rejection rates have been significantly brought down. Now, inspection standard. Now, when it comes to the bottling industry, it is governed by a lot of standard bodies which often review the quality control system in this industry, in these companies. Now, when the manual system was installed, what I could hear out from the production managers and maintenance managers from this bottling industry is there are no much solid evidences for them to prove during the audit that their inspection is of high quality. Even though maybe your manual inspection is doing well, but still you don't have substantial evidences to prove to the auditors saying that my system runs well. But introduction of automation and the logging system, always we have insightful reports which comes out and which can actually say that what are the different type of defects, what type of bottles are coming in, what time of the year a particular defect is more prominent, how are we addressing that. Those data are very valuable to bring transparency in the audit process, which helps us building confidence with the standard bodies, which in turn help the system improving the quality of the control processes. Last but not the least, all these things finally gets a positive thumbs up for the brand. Improved quality, reduced recalls or returns, and an improved customer feedback builds your brand and gives you the competitive edge. This will become generally the unique selling point for you in the competitive world. So I see these many key takeaways by installing an automation system which is using AI in your visual inspection. So in the interest of time, I will request to move forward to the next slide. Yeah, I want to quickly mention about this point here. Now, as you all know that we are installing this system in a industrial environment. And the industrial environment where we are installing this system is highly challenging with respect to environmental factors. Basically, the temperature variations will be there. The humid condition can change throughout the year. There will be a lot of noises in the production line. There are dust which comes along with inspection bottles, which can actually really harm the inspection process. Many items like that. Now, water will be there since it is water bottle, right? Even if we call it as an empty bottle detection system, the bottle which comes out from the market, not always as a return bottle, not always need not be empty. So it comes with waters, any type of defects, which can actually in fact harm the proper functioning of our system also. So with predictive maintenance, what we have introduced into this particular system is not only the model is intelligent, we made the machine also intelligent to understand when and where it needs maintenance so that it can proactively inform the maintenance team that I need maintenance by this time so that I will not come down in my detection accuracy. So what we have seen is This has been a great feature which we have added to our system, where our quality of our inspection is never hampered with respect to external factors. It could be the camera calibration check, the illumination check. It could be dust formed in the camera, which is really impact the image quality of the system. It could be the sound which is unusual, which comes out, where we can see that maybe there is a wear and tear with the bottle or with the motion system. There we can actually inform that maintenance is required, and so that the system continuously work. So this is one of the key features which we added to the system to make sure that we have a continuously working, reliable inspection system for the customer, which never compromise on the inspection process. Moving on. Yeah, so we are almost coming to the end of this presentation. So as a final thought, I just want to summarize here that the importance of having a quality control system basically in the water bottling really impacts the brand of your company, primarily in providing better quality products to your consumers, avoiding rework and customer escalations, and coming up with insights and adaptive system where you know that what is happening with your bottles which are going out to the market and then coming back, where the competition is very high. And when you talk about competition, there are cases, real cases, where we see that the defects are being sometimes induced so that it can negatively impact the brand of the particular company. So a very strong, accurate, automated AI inspection system is a need of the hour for the bottling industry, and a better system always build your brand to have a high position in this industry. And AI is the solution. All the legacy customers who are actually using the limited verification process what they have installed will be encouraged to move to automation system, where the power of technology can be used to improve your quality control system. Having said that, I will actually take a pause here and then hand it over to Aditi to take any of customer questions which are coming through for the session. Thank you. Thank you.
Thank you so much, Greenu and Bhavika. I think that was a very insightful session which helped us understand about the surface defect detection for bottling. And we had a deep dive into the entire process, into how we are able to establish a system for the bottling industries and how it is scalable and how it can help the bottling business ace their customer satisfaction. So now, as was mentioned earlier, so we received quite a few questions during the session, and the floor is now open for question and answers. So I think I'll be taking up the first question that came up very early in the presentation. So just give me a second. I think, yes, this question is by Haley. So Haley wants to ask, what's the lead time to deliver a bottle inspection system? So Greenu and Bhavika, who would any one of you can take up this question?
Yes, Aditi.
Okay. So primarily I'll take it up, and Bhavika, if you can add your thoughts into that, that will be great. So primarily the lead time for installing the system, right? That's what, right? So as I was mentioning in my earlier presentation, probably you don't get any off-the-shelf product because this is primarily dependent on customer by customer basis, because the requirements from the customer varies, and then probably we need to define and design this particular system for specific needs for the customer. But the model part as well as the hardware, we really make sure that the footprint is minimum, so that we don't have to really make every system from the scratch. Having said that, probably the minimum lead time can be around 3 to 4 months to get a full-fledged AI-enabled inspection system getting installed, piloted, and running in your production line. Hope I answered your question.
Thank you, Krinu, for that quick answer. We are very happy seeing the number of questions that have come our way, but due to time constraints, we'll be able to take only one last question for this session. So this question is from Vishal, who is asking, does the hardware system allow customization on different bottle profiles? Bhavika, will you be able to take up this question?
Sure, Aditi. To answer the question that the hardware system allows customization on different bottle profiles, as we have gone through the slides of the key features, we do mention that our system has a flexible, adaptable on this inspection of different bottle profiles. So what we do is, in our initial study for the requirements which we gather from the customer side, we do understand the possibilities of inspecting the different bottle profiles. Based on that, we design our hardware or software in such a way that can allow inspecting on these bottle profiles which came in picture during our requirements without disturbing the production throughput. So to answer that, yes, we can.
Yeah, definitely. So Bhavika answered it correct. We'll be able to actually support the different bottle profiles. And also one more requirement sometimes which comes from the customer will be like, in future I may have some sort of changes in the profile. So how flexible will be your hardware design will be. So we gave a thought on that also. Probably we allow some sort of percentage of tolerance with respect to all the existing profiles. Maybe we may give some more tolerance so that not significant variation, but minor variations within the tolerance limit will support. Yeah. Thank you, Bhavika.
Okay, so I think that brings us to the end of the session. There are still a lot of questions which we could not take up in this session, but we're sure we can get them to you over a mail, and you all can reach us at hello@imagevision.ai. We'll be coming up with more such interesting, insightful webinars in the future. So please follow our page on LinkedIn, and you can follow us on Twitter, as well as you can check out our website, which is www.imagevision.ai. And I think it's been very good that you all have taken out a time for us and given us a chance to talk about this topic at length. I would once again like to thank all the participants, our panelists, and everybody for making this a huge success. And rest of the questions, surely we'll get you through the mail. Once again, you can reach us at hello@imagevision.ai. This is your host, Aditi Argal, signing off. Thank you. Good night. Good evening. Good day.